Hello, welcome back to Learn Physics. In today's topic, we are going to discuss the previous year question paper, that is 2018 question paper. Okay, so today it is here in physics part, first one start with the second question. Okay, write the energy conversion that takes place in a hydropower plant. In hydroelectric power plant, what is the energy conversion which is happening? In dams, it is potential energy. From dam, water is coming down. That means it has kinetic energy. It is under motion. So kinetic energy. So that one is helping to turn the turbine, isn't it? So mechanical energy is converting to electrical energy. Okay, potential energy, kinetic energy, mechanical energy into electrical energy. That is what happening in the case of hydroelectric power plant. Okay, so the next question is question number 5. Fifth question. If the image formed by a spherical mirror for all positions of the object placed in front of it is always erect and diminished, what type of mirror is it? Draw a labeled diagram to support your answer. At all positions, we will be getting erect diminished image. Erect means it will be virtual also. Virtual, erect and diminished for all position. Which type of mirror is it? It is a convex mirror. Okay, so it is a convex mirror. Convex mirror is the answer, and draw a ray diagram to support your answer means you can draw a diagram for that. Convex mirror, this is principal axis. At one position you can see that you can keep the object, rays which are passing parallel to the principal axis. What will happen after reflection? It will go reflect and go from the principal focus. The ray of light which is incidenting at a point which appear to incident through the center of curvature will retrace its path. So here it will go like this, and here through the principal focus, so image will be getting over here. So it is an erect image. So here you should understand how we will be drawing the diagram. See, it is the ray which is passing parallel to the principal axis. After reflection, it will be coming from, it will diverge and go. Since it is a convex mirror, and while diverging, it will go from the principal focus. The ray of light which is incidenting, it appears to incident through the center of curvature, or center of curvature. What will happen? It will retrace its path. Okay, so the next question is 11th one. State the law of refraction of light. Explain the term absolute refractive index of a medium and write an expression to relate it with the speed of light in vacuum. So what are the laws of refraction? Incident ray, reflected incident ray, refracted ray, and the normal will lie on the same plane. Okay, that is first law of refraction. First law of refraction means incident ray, refracted ray, and the normal should lie on the same plane. Second law is the ratio of sine of angle of incidence to the sine of angle of refraction is a constant, which is called a Snell's law. Okay, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. That this is called as Snell's law. So what is this constant? Okay, that constant is called as This refractive index of the medium. Refractive index. This ratio is called as refractive index. Representation is N. If the ray of light is incidenting at one medium and refracting through the second medium. Okay, so refractive index of the second medium with respect to first one is equal to sin I divided by sin R. Okay, this refractive index of second medium with respect to first medium is sin I by sin R, and first medium to second medium means it will be opposite. That means N21 is equal to 1 by N12. Okay, then one more question was there. Write an expression to relate it with the speed of light. So refractive index N is equal to C by V. Okay, this is the this N is equal to refractive index of the second medium. See, if the second medium is a denser medium and first medium is vacuum, then we can say it, or air if we are considering refractive index of the second medium with respect to the first medium, N is equal to C by V. Okay, so I think it's not working properly, so I'll take another pen. So next in that itself, an OR question is there. What is meant by power of a lens? Write its SI unit. A student uses a lens of focal length 40 centimeter and another of minus 20 centimeter. Write the nature and power of each lens. What is meant by power of a lens? Power of a lens is the reciprocal of focal length, you can write, or it is the ability to converge or diverge the light ray. Okay, that is called the power of a lens. It is the ability to converge or diverge the light ray. That is power, or we can define it as it is the reciprocal of the focal length. Okay, and its SI unit is diopter. Representation is D. Okay, and a student uses a lens of focal length 40 centimeter. Another is using F1. Another is using of minus 20 centimeter. Write the nature and power of each lens. So power formula is 1 by F. For that we should convert it into meters. So 0.4, this is minus 0.2 meter. So P equals 1 by 0.4, that is 10 by 4 diopter. Here P equals minus 10 by 2, that is 5D minus. So what is this positive and negative? What is the nature? Nature means positive and negative sign. What it represents? If it is positive means what is the nature? Nature means if it is positive, focal length is positive means we will be getting a convex lens. And focal length is negative means we will be getting a concave lens. That will be a concave lens. For concave lens, virtual images, right? This side only we will be getting the image. Convex lens means we will be getting the image at the other side. So always focal length negative means it is a concave lens. Focal length positive means it's a convex lens. Okay, same like mirror. Mirror you know, right? Mirror means, see, like this. Concave will be negative. Convex means it is like this. So convex means focal length is positive. Okay, the same only here also. Okay, negative means it will be concave, positive means it will be convex. Okay, clear? So the next one is, show how would you join 3 resistors, each of resistance 9 ohm, so that the equivalent resistance of the combination is 13.5 ohm and 6 ohm. So 3 9 ohm, this is 12th question, 3 9 ohm resistors. Okay, how we can connect? Effective resistance should be equal to 13.5 and 6 ohm, not 9, 6 ohm. How we will be getting these two? Okay, so 3 9 ohm resistors are there. If all are in series means it is 27. Okay, so all are, see this is greater than 9, right? So it will be in which one? It will be in series also it will be. Okay, so all the three are not in series, then it is 27. So 2 series, while we are considering, what we will get? 18 we will get. So 2 are not in series also. Okay, so 30 less than that. So 1 is in series with other 2 parallel. Shall we do like that? See, 1 is in series, so 9 plus, and other 2 are in parallel. So R1, R2 divided by R1 plus R2. If I am considering that one, 9 plus 9, 18. So we will get 9 plus 9 into 9 divided by 18. So here that is 4.5, 13.5. Like that you can do the rough work. So you how you should think, that only I am telling over here. So 2 are in series means it is 18. That is not coming. So 3 obviously it won't be. Okay, since 13.5. Then 1 is in series with other 2 parallel. Whether that is working, we should try. So we tried that one and we got the answer. Now you should draw the diagram. 1 and the other 2 in parallel. Okay, this is 9 ohm and this is 9 ohm and this is 9 ohm. Now you should show. See, this is Rp equals R1 R2 divided by R1 plus R2. Okay, like this you should show. 9 into 9 divided by 18. So it is 4.5. So 9 plus 4.5 will give you 13.5 ohm. Like that you should show the effective resistance. Okay, so now 6 ohm. So all the 3 in series also can be. So first we are trying that one. See, 2 are in parallel, we know. So all the 3 are in parallel, whether it is working or not. So 1 by Rp equals 1 by R1 plus 1 by R2 plus. This is a trial and error method only. 1 by R3. So 1 by 9 plus 1 by 9 plus 1 by 9. So it is 3 by 9, so 1 by 3, so it is not working. Okay, so Rp is 3 ohm, it's not correct. Now we should try. See, 2 are in series, 2 are in parallel, it is not working, right? So 2 are in series and 1 in parallel, whether it is working. So here 2 in series means first 2 are in series. So I am considering R1 plus R2. So 18 ohm. So this 18 ohm is in parallel with the 9 ohm. We are trying that one. So 1 by R effective is equal to 1 by 9 plus 1 by 18. So 18 into 9 plus 9 plus 18. So 27 divided by 18 into, so it is 6 ohm we got. So that is correct. This should be the rough calculation that which you should do. Okay. Then now you can try. So 2 are in series. First 2 are in series and which should be in parallel with that. Okay. So 9 ohm, 18, and which is in parallel with the 6 ohm. Okay, in parallel with the 9 ohm. So we got the answer as 6 ohm. So like this you should show by calculation as well as in diagram. Okay, I did my calculation in the workplace like that, and you can't say. So all the values, otherwise at least half or 1 mark they will reduce. Okay, so better go for all the calculation, let it be there only. Okay, the rough calculation, if more calculations are there on the right side, you can keep the calculation part. Okay, so the next one is write Joule's law of heating. 2 lamps, one rated 100 watt 220 volt and the other 60 watt 220 volt are connected in parallel to electric mains supply. Find the current drawn by two bulbs from the line if the supply voltage is 220 volt. Write Joule's law of heating. What is that? See, this is 12th question or question A part. Joule's law of heating states that heat supplied or heat generated in a conductor is directly proportional to the square of the current, is directly proportional to the resistance of the conductor, is directly proportional to the time for which the current is flowing through the circuit. So we can write it as H is proportional to I square RT. Since proportionality constant is 1, we can write it as H equals I square RT. Okay, this is Joule's law of heating. Square of current directly proportional to the resistance of the conductor, directly proportional to the time for which the current is passing through the conductor. Okay, so then second question, second part is a numerical part. There's two lamps, one rated 100 watt and 220 volt. Okay, P1 equals 100 watt and V1 equals 220 volt, and the other P2 equals 60 watt and V2 equals 220 volt are connected in parallel. Okay, find the current drawn by two bulbs from the line if the supply voltage is 220 volt. Current we should find out. Current will be different in parallel connection. So I1 we can find out, here I2 we can find out. What is the relation connecting P, V and I? P equals V into I. Therefore I1 equals P1 by V1, that is 100 divided by 220, that is 5 by 11 ampere. And here I2 equals P2 by V2, that is 60 divided by 220. So here it is 3 by 11 ampere. Okay, so these are the I1 and I2 for the respective lamps. Okay, clear? So that's all for today, and in next day I'll be continuing, next week I'll be continuing with this the question paper, the rest of the parts, and I hope it is clear for you, and I know exams are very nearby and you are thorough with that, thorough with the portions I guess, and all of you work hard. Anyway, only few days are there to for the exam to get over, right? So try your maximum. See, if you are trying hard now, when you are getting the result, it will be the happiest moment for you. Okay, try to get that happiest moment for you. Okay, so do your maximum and work hard. Okay, then surely you will get the result. Okay, don't waste your time by simply opening the book and keeping trying to convince others that you are studying properly. Try to convince yourself that you studied properly. Okay, so that's all for today, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.